the graph of y equals x to the 6th minus 10x to the 5th plus 29x to the 4th minus 4x cubed plus ax squared lies above the line y equals bx plus c, except at three values of x, where the graph and the line intersect. What is the largest of those values? We have the graph of y equals x to the 6th minus 10x to the 5th plus 29x to the 4th minus 4x cubed plus ax squared, and it lies above the line y equals bx plus c, except at these three values of x, here, here, and here, for which the graph and the line intersect. I will call them u, v, and w. So if we subtract y equals bx plus c from the original 6th-degree polynomial, we would get y equals x to the 6th minus 10x to the 5th plus 29x to the 4th minus 4x cubed plus ax squared minus bx minus c. And this is greater than or equal to 0, where equality holds when x equals u, v, and w. Each of these roots, u, v, and w, is a double root. So we can conclude that this polynomial, x to the 6th minus 10x to the 5th plus 29x to the 4th minus 4x cubed plus ax squared minus bx minus c, this is the square of some third-degree polynomial whose roots are u, v, and w. And the leading coefficient is 1. So we can say that it is the square of x minus u times x minus v times x minus w. Instead of treating this third-degree polynomial we're squaring as a product of three linear factors, we can just go to its actual coefficients and represent it as x cubed plus px squared plus qx plus r. And then all that'll be left would be to find the largest root w of x cubed plus px squared plus qx plus r, since that would be the largest value of x where the graph and the line intersect. So squaring this, we have x cubed plus px squared plus qx plus r, and we have to find p, q, and r. So if we square this, the coefficient of x to the 6th will be 1. What will the coefficient of x to the 5th be? The coefficient of x to the 5th is equal to p from this and another p from this. So that's p plus p, which is 2p. Okay, and then what's the coefficient of x to the 4th? Well, x to the 4th you can get in three ways. You can get from x cubed times qx. You can do px squared times px squared. Or you could do qx times x cubed. So the coefficient of x to the 4th is just q plus p squared plus q. And that's equal to 29. And the coefficient of x to the 5th is equal to negative 10. Now, what's the coefficient of x cubed? Well, the coefficient of x cubed is equal to r plus pq plus pq plus r. So we have the coefficient of x cubed is equal to 2r plus 2pq, and we expect that to be equal to negative 4. The other coefficients I don't really care to find, because they're just a, b, and c, which don't really matter as of now. So x to the 5th, 2p equals minus 10, so we can get that p is equal to minus 5. Substituting that into here, we get that p squared plus 2q equals 29. So we have 25 plus 2q is 29, and therefore q is equal to 2. And now 2r plus 2pq is negative 4. So 2pq is just 2 times negative 5, which is negative 20. So we have 2r minus 20 equals negative 4. And so 2r equals 16, and r equals 8. So we have pq and r equals negative 5, 2, and 8. So we have x cubed plus px squared plus qx plus r is nothing but x cubed minus 5x squared plus 2x plus 8. And so we have to find the largest root w of x cubed minus 5x squared plus 2x plus 8. And if you play around, you might notice that negative 1 is a root of this polynomial, because 1 plus 5 plus 2 is equal to 8. And we have, if we plug in negative 1 for x, minus 1 minus 5, because negative 1 squared is 1. And then 2 times negative 1 is negative 2 plus 8. Minus 1 minus 5 minus 2 plus 8, that's obviously equal to 0, because minus 8 plus 8 is 0. So we have x equals -1 is a root of this polynomial x cubed minus 5x squared plus 2x plus 8. Now, if we let the other two roots be v and w, then we can use Vieta's formulas to find v and w. We know that the sum of the roots is equal to minus b over a for cubic polynomials. So -1 plus v plus w is just minus b over a, and that's equal to 5. So we have v plus w is equal to 6. And then the product of the roots is equal to minus d over a. So minus vw equals minus 8 over 1, which is -8. So we have vw equals 8, and v plus w equals 6, because -1 plus v plus w is equal to 5. It's not too hard to see based on this that v is 2, and w is 4. So the polynomial has roots at -1, 2, and 4. The largest of these values is 4. And looking back to our answer choices, we see that 4 corresponds to answer choice A, and we are done. Thank you for watching my YouTube video, and please follow my channel if you would like to see more videos.